This is Mr. Beck Does Your Homework. This is AP Physics Homework 4.3 on torque, questions 5 and 6. A 563.4 Newton window washer, so they already give me his weight in newtons, is standing on a uniform scaffold supported by a vertical rope at each end. So let's see, I've got a vertical rope, I've got a scaffold, I've got another vertical rope. The scaffold weighs 262.4 newtons and is 4.91 meters long. Assuming the window washer stands 1.02 meters from one end, what is the force on the farther rope? So let's see, I've got 4.91 meters, so this is going to be 4.91 meters long. The scaffold weighs 262.4. Where am I going to put that force? Well, that's going to be the force of gravity, and I'm going to put that straight in the middle of the scaffold. So that is going to be 262.4 newtons. And if that's 4.91 meters, then this distance is going to be half of each of those. The window washer stands 1.02 meters from one end. Well, half of 4.9, that's going to be about 2.5. So he's going to be standing like here. So there's my window washer. So the gravity on him is going to be right here. So that's going to be 563.4. So I'm trying to figure out these. So he is 1.02 away. The center of the bridge is going to be half of 4.91, so that's about 2.5. So I'll figure what that is later when I need it. What is the force on the farther rope? Okay, so I'm looking for the force this way of tension. Well, I want the force on this rope. I don't know the force on this rope. I do know these two. So since I don't know the force of tension up here, I don't know it and I don't care it, I'm going to pick that one as my pivot point. Now, if I think about how this one reacts, if that's my pivot point right there, then this one is going to pull it clockwise. This one is going to pull it clockwise. And this tension is going to pull it counterclockwise. Since it is not moving, it's at equilibrium, I know that these two torques have to equal this torque. Not the forces, but the torques. So I can do it clockwise equals counterclockwise again. So let me see, if I say, usually I'm saying counterclockwise equals clockwise, so I'll do it that way. Counterclockwise, this is the only one that's counterclockwise. It's trying to spin it up around this way. So that is going to have an RF sine theta for that one. And then I've got two clockwise torques. So I'm going to have an RF sine theta for the first one and an RF sine theta for the second one. Well, all of my sine thetas are 90 degrees, 90 degrees, 90 degrees. So the sine of 90 is 1. So I've got an RF. This R is going to be the whole length of the scaffold. It's from this end to this end is the whole length of the scaffold. For me, that's 4.91 meters. This force is what I'm looking for. It's the force of tension. That's going to equal, let's say, the window washer. Well, he's standing 1.02 meters from this end. So he's 1.02 times his force of 563.4. Now, the scaffolding itself has a weight, and that's going to be pulling down in the center. So the radius of that is going to be half the length of my scaffolding. So that's going to be 4.91 over 2. It's going to be half the length of the scaffolding because the center is halfway from this end. So that's halfway from this end, and the force is 262.4 for me. So now I have an RF equals RF plus RF. If I do this math, add these together, divide by 4.91, I will get the force of tension in the right side rope. My next question says, what is the force on the closer rope? So now I want this one, okay? So now I want this force that I didn't know before. I could go through another torque problem and pick any point as the pivot point and do this whole RF sine theta thing. Or, now that I know this and this and this, what I can do is I can do a simpler equilibrium problem, just ups and downs. This force and this force up must equal this force and this force down. So I can say up equals down. So the total amount of force up is going to equal the total amount of force down. Well, the force up is going to be my force of tension, we'll say, in the left rope. So this is FTL, and this one will be my force of tension in the right rope. So force of tension in the left rope plus the force of tension in the right rope must equal these two forces of gravity. That's going to be a force of gravity plus a force of gravity. The force of tension in the left rope is what I'm looking for. So that's going to equal, if I subtract this from both sides, I'm going to get my first force of gravity, which is 563.4, My second force of gravity is 262.4, and from that I am going to subtract my answer from over here, this force of tension. And that will give me my force of tension in the left side rope. By doing this and this, minus that.